In this lesson, we're going to be doing some sequences and series word problems. You want your formula sheet out for this, even though I'll have it kind of on every slide. You want to be able to look at your formula sheet and see how you use it also. So to start, it says Alina made $35,000 during the first year of her job. Each year, she received a 10% raise. So when I'm looking at this, if she's getting a 10% raise, that tells me that we're talking about a geometric problem. 35,000 seems to be her A1, right, her starting salary. I'm looking for her common ratio, which is 10% her raise. So if you think about a 10% raise, that means that you're making 100% of what you made before, plus an additional 10%. So to calculate her year-to-year increase, you would have to take the 100% of what she made before, plus an extra 10%. So that's really 110%. So that's 1.1 as a decimal. So 1.1 is her R. So now if I want to find what she made during her first, okay, so that's our information. Now it says in part A, how much did she earn in her 10th year on the job? So this right here is N. We're looking for A10. I'm looking at this formula right here, because I'm not looking for the sum of all 10 years, I'm just looking for the 10th year. So I'm going to show this work up here since I have a lot of room there. So A sub 10 equals A1 times R to the 10 minus 1. So really what I need to do is I need to go to my calculator. I'm going to take 1.1 to the 9th power, and then I'm going to times that by 35,000. And I get $82,528.17. So I'll come back to my screen here. And I'd say in her 10th year, she's making $82,528.17. So think about that. If you have a starting job there, look at what you're making after 10 years with 10% raise. That'd be a lot more money. Then part B says what were her total earnings during the first 10 years. So now we're adding year 1 plus year 2 plus year 3. So now that moves us into either of these formulas. I prefer this one because my calculator will do the work for me, and it's just a little bit quicker. So I'm going to find her summation from her first year of work to her 10th year. Remember, A1 still goes here according to the formula. Her R is 1.1. And remember with this one, on our calculator, we always leave that the variable. So N minus 1. I'm going to go to my calculator and plug that in. So I'm going to go to math 0. And we use X. So X1, we're going to her 10th year. And then we'll go, oops, sorry. Every time I hit enter when I need to hit arrow. There we go. 35,000 is A1 times 1.1 raised to the X minus 1. So take a look at how that's put in there. And I don't have to put parentheses around that because it will do the exponent before it multiplies by 35,000. So when I hit enter, I find that the sum for all of her years is over $500,000. So when I come back, I'll take that number and put that as my answer here. So after 10 years, she is making $557,809.86. Okay, so there's one. Number 2 now says a piece of machinery valued at $80,000 depreciates $8,000 the first year, $7,500 the second. Depreciates 2, I think that's how much it's going to go down to, or how much it's going down. So $7,500 the second year and $7,000 the third year, and so on. How much did the car depreciate the 8th year? Now I can see that the sequence here doesn't involve this 80,000. That's just my starting point. So I'm going to make a sequence here of what's happening. This is how much it's depreciating. So if you're looking here, hopefully you can see that this is A1. It appears that I'm going down by the same amount every time, so it's an arithmetic sequence. And then my common difference is negative 500. And it says, how much did the car depreciate in the 8th year? I'm not looking for the total 8 years. I'm just looking for the 8th year. So that would be this formula right here. So I'm going to say A8 equals A1 plus N, which is 8, minus 1 times negative 500. So I'd have A8, I'm not even using my calculator for this, 8,000 This is 7. 7 times negative 500 is negative 3,500. If I take 8,000 minus 3,500, I get 4,500. So in the 8th year, I would expect it to depreciate $4,500. Okay, those are kind of a simpler word problem, those first two. Now in number 3, see we have more words, and we're going to just be maybe a little more what to look for here. So it says KARP hears about KDUZ giving away Twins tickets and comes up with a giveaway of its own. KARP will give away $106.90. Remember, on the dial, it's 106.9. That's creative, huh? That much cash on the first day. Okay, so this much cash on the first day. I'm just going to kind of label it here. That seems like that'd be A1, doesn't it? And $1,229.35 on the last day. So on the last day, so this seems like it's my AN. I'm not sure how many days there are yet, but that's how much they give away on the last day. Adding the same dollar amount, that tells me this is arithmetic. I'm adding the same dollar amount each day to the previous day's prize money for a total of 70,000 some. So total, that's my SN. After all those days, it's going to be that. How much will be given away on the second and third day? I don't know how much they. I know how much they gave away on the first day, right? I know A1. I don't know how many days they're doing it, and I don't know how much they're doing every day. Does that make sense? So if I want to see the total on the second and third day, I'd have to find N, or D, I mean. I'd have to find D. So to find D, I'm thinking I should maybe use this formula. Does that kind of make sense to you? So I'm just going to scroll this up a little bit. So it says AN. Well, I know on the last day, AN, we labeled that. That was that 12. Sorry, I can't see that, so I got to look back. 1229.35 equals A1. Well, A1, the first day, is 106.9, right? Plus, and I don't know how many days they're doing it, and I don't know that. So when I look at this formula, this is the one I think I want to use, but I don't know N and I don't know D. So now I'm going to have to use either this formula here, which we haven't used yet, or this one here to find N and find D. So let's just see, do I know, I'm just going to try this one first right here. I know SN, I know A1, I know AN. So I know most of this formula. So I'm going to come over here and say SN. So I'm going to write this formula down. Can't really read it very well. Let me make sure I copy it right. Yeah, there we go. Okay. So I know SN is the 70,821.25. I don't know N, that's what I'm trying to find here so that I can find D. And then I know A1 is 106.9, and I know AN is the 1229.35, all divided by 2. So I'm going to solve this equation. When I go ahead, let me scroll down here for you. When I go ahead and maybe multiply both sides by 2 right away, so get rid of those 2's, multiply that by 2. So I'd have that 70,000, blah, 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 times 2. That ends up being 141,642.5. You can go ahead and do that on your calculator if you like. And then when I go ahead and add the 106.9 plus the 1229, this is what I get. So now to solve for N, I divide by 1336.25. And N, this is how many days they're doing this contest for. Oh, look at that. 106.9, how creative, because I can't do it for half a day. They're doing the contest for 106 days. So now I'm going to come back up here, because I need to find out how much to add every day to the contest. So this is now 106. Now I have all of my variables in here that I would need, except for the D, which is what I'm looking for. So I'm going to minus 106.9 from both sides. And when I do that, I get 1122.45. And then that equals 106 minus 1 is 105D. So to find my D, I'm going to divide by 105. And when I do that, I get my D to be 10.69. Look at how creative they are, 106.9 again. So they're adding $10.69 to how much they're giving away every day. So what I found is on the first day, they gave away 106.9. The question says how much will be given away on the second and third day. So I have to add 10.69 to this to find out the second day. So second day, when I add those together, would be 117.59. And then I'm going to go ahead and add another $10.69 to this, and I get 128.28. So this is how much. This is actually answering the question. The second 30, that's how much they give away. That was created by the radio station. Isn't that a good idea to do? Okay. Now we're getting to the rubber ball problem. And this is the one that's going to drive you crazy in your notes a little bit. So I want to just read it to you and talk to you about it really quick, and then we'll do it. So it says a rubber ball, or a bouncy ball you can think of, is dropped on a hard surface. So think of me standing in my classroom right now, dropping this ball on the floor. It takes a sequence of vertical bounces. With each bounce, the ball loses 2/7 of its preceding height. The ball is dropped from 21 feet. So on Excel math, it's not going to say loses 2/7. It's going to give you the actual number. So if it loses 2/7, it's really keeping, which is what Excel math is going to give you. It keeps 5/7 of its height. So this is really its R. Okay, so this says loses 2/7. We just want to show you one like that. On Excel math, they'll give you the actual number. So 5/7 is our R. Hopefully you can see this would be geometric because it's not the same amount every time. So we're working from this category over here. Now I want you to picture a ball dropping. So I'm going to come down here and draw this picture. Here's my classroom. Here's me with my hand, get those fingers, at 21 feet. Okay, I'm starting at 21 feet. So that's above my classroom. So my ceiling's raised. Now, when I bounce a bouncy ball in the classroom, which if I had one, I would show you. It's going to start here. My hand's going to release it, right? There's my face. And the ball's going to come and it's going to hit the ground. And it's going to bounce back up. Now, it doesn't bounce as high, right? It's going to hit the ground, bounce back up. Hit the ground, bounce back up. Hit the ground, bounce back up. And this sequence repeats until all of a sudden it kind of does one of those numbers, and it'll start rolling. That's how a ball bounces, right? So when we're looking at this, it's going to lose 5/7 of its height. The height of the ball comes down. You never bounce a bouncy ball when it keeps bouncing without more force. It loses some of those bounces, right? That's kind of a physics problem. Actually, this is a physics problem. So when we're looking at this, we're looking for I'm going to make a sequence here. It says, what height does it reach after the fourth bounce? So on the first bounce, actually before the first bounce, so my first term is 21. This is when I'm standing, holding it. See my hand down there? I'm standing, holding the ball. That's my first bounce, or my first starting point. Then after the first bounce, it'll be 21 times 5/7. So I'm going to go ahead and type that in my calculator. 21 times 5 divided by 7. And I get 15. So that means my next bounce is 15. I'm going to go ahead and take that answer, times 5/7 again. The next one is 10.7. Then I do it again, 7.6 or 7.7. So this is what's happening in my sequence. So let me go put those in here. So 21, 15, what was it, 10.7 maybe? And then 7.7. This is just to show you an idea of it. Now this is kind of a new concept. The first bounce happened right here. After the first bounce, that was 15. So this is actually the first bounce, and this is the second bounce, and this is the third bounce. This is bounce 0, before it even happened. But it is my first term. So when they're asking for the fourth bounce, they're looking for this right here, aren't they? What term is that? 1, 2, 3, 4, 5. We're looking for A5. Okay, so A5, I'm going to go ahead and put here. I'm going to come and do this right over here. A5, so this is for letter A. It says, what's the height it reaches after the fifth bounce? We're not looking for all the sum of all the heights. We're just looking for the fifth bounce. Again, we're geometric. So A5 equals, well, the first bounce is 21. A1, we started at a height of 21. My R is 5/7, and I'm looking for 5 minus 1. So I'm going to take 5/7 to the fourth power times 21, and that should be my answer. So I'm going to come back to my calculator. I'm going to go 5/7 to the fourth power times 21. And that is 5.5. Now, just to show you, it should have been this answer up here. Oops. Times 5/7, shouldn't it? I mean, I know we're doing that the long way, but I want to prove to you how that works. So we should get the same answer there. And we do. So the formula works for this. So 5.47, all right. So we'll say A5 equals 5.47, and that's what would have gone in this spot right here. And that's my answer for A. Now B, this is the one that's going to give you a little more problems on your Excel math. So I'm going to erase this here just to give myself some room. You guys already have that written down, or you can rewind. It says, what's the total distance traveled when the ball hits the ground for the 5th time? So I'm looking for the sum of the 5 hits. So 1, 2, 3, 4, 5, right there. I'm looking for the sum of those distances. Remembering that my first term really is the 21. So I'm going to do a summation. And I'm going to start at the first term, and I'm going to go to the what term? 1, 2, as you count, as you go across. 3, 4, 5. My 5th bounce, right? I'm going from 1 to 5 for those. So 1 to 5 for my first term and my 5th term. And I'm looking for the sum. So then it says A1 is 21, 5/7, and then we'll go n minus 1. Now this is going to give me just either my downs or my ups. So see, the distance actually has 2 distances here. Here's one group of distances. And then we have to go with these ups. This is the other group of distances. There's a couple ways I could show you to do this. But what I want you to notice is that the downs have an extra term right there. This 21 feet that it falls in the beginning makes a difference because it doesn't ever go up 21 feet. So we're going to plug this in our calculator, and this is going to give us the downs. Or excuse me, yeah, the downs. The ups don't have 21 feet. I think I just said downs. So when I go to my calculator here, we're going to go to math 0. And I'm going to say x1 to 5. And we started at 21, parenthesis, 5/7. And then raised to the n minus 1. Okay, so that's what we have written down. And I get 59.83. Does everyone see that? 59.83. So those are my downs. So this equals 59.83. My ups is going to be the same as this, but minus 21, because it doesn't go up 21 feet. So to find your answer for the ups also, instead of having to do another one of these, we're going to take this answer and we're going to subtract 21, or we can times it by 2 and subtract 21. So we'll times this answer by 2, and then we'll subtract 21. So subtract your original. So I'm going to go on my calculator and do that. Times this by 2. That would be double. Now I got to take away I can't count that 21 twice. So I'm minus 21, and I get 98.67 feet. So that answer, whatever I got there, 91 was it? No, 98. 98.67 feet. And this is one you might want to double check with me tomorrow if you have questions on it. I just don't want to make you watch a much longer video to go into it anymore. Okay, our last one like these, another radio station giveaway. So it says KDUZ is planning to give away a total of 1,425 Twins tickets in the month of June. So total number of tickets is 1,425. Does that make sense? And then it says the station wants to increase the number of tickets given away each day by 3. So that sounds to me like we're dealing with arithmetic, right? It's going up by 3 every time. That's my D. So I'm looking at that. And then it says, how many should the station give away on the first day? So it's looking for A1. I don't know A1. So I want to try to find A1. That makes me think I want to maybe use this formula. So as I go to start to plug that in, I would say, do I know AN? I know there's 30 days in June, right? Is it doing it in June? So I know N is 30. And it says they're planning to give away a total of 1,425. So the total tickets is 1,425. That's the total number of tickets they're giving away, right? So that would be like SN, wouldn't it? So after 30 days, the sum of the tickets should be 1,425. Does that make sense? And I don't know AN. And I don't know A1. So you see how that first formula wouldn't work? I don't know those two variables. So I can't use that first formula. So let me just see if I can use this one here. I know SN, but again, I don't know A1AN. So here's a case where we're going to use this new formula we've never tried. So I'm just going to show you what it is. Sn equals n times 2 A1s plus n minus 1 times d over 2. Now, I know everything up there except A1, so I can go ahead and plug this in. So I'm going to do that. S30 in this case is 1425 equals 30 days in June, right? That's where I got the 30 from. I had to know there were 30 days in June. And then I have 2 times A1, A1 is my variable, plus 30 minus 1 times 3, because they're giving away 3 tickets a day, divided by 2. So as I keep working here, I'm going to go ahead and simplify this. I'll times both sides by 2 right away. Oops. Hold that. There we go. So on this side, I have 2850 equals 30 times 2 A1s plus 29 times 3. So if I take 29 times 3, I get 87. So I'm going to divide both sides by 30 right away. 2850 divided by 30 is 95 equals 2A1 plus 87. How's that looking so far? So now I'm going to subtract 87 from both sides. So I get 8 equals 2 times A1 divided by 2. So A1, on the first day, I give away 4 Twins tickets. Now, I don't even remember what this question was asking for. Is that the question? How many should the station give away on the first day? There's the question. So on the first day, they should give away 4 tickets. Now, if they were asking on the 8th day, how many are they going to give away? You can now plug this in and you have all your variables, but that's all they asked for. So I'm done with that problem. Now, the last two deal with our recursive formula, and this is what you will see on your ACT, this exact question pretty much. So it says, Dr. Franklin begins the experiment with 100 bacteria in a container. She finds that the number of bacteria present at any given time is modeled by the following recursive formula. So you have to be able to read this. This, when I'm looking at it, says I start with 100, and then to get to the next term, I multiply by 2. So you take the previous term, that's what that n-1 means, previous term times 2. So it's going to be doubling every time. N is the number of hours after the beginning of the experiment. How many bacteria are present after 5 hours? So you don't have to write them all out. This is kind of, we start with 100. Okay, and then when we start, here's the part that's different. My next term that goes right there is the first hour. That's after 1 hour. So after 1 hour, so this is really 0. No time has passed. I started with 100. And then I have 2 hours, 3 hours, 4 hours, 5 hours. That's what we're looking for here. And you can go ahead and list it all like this. That's an okay way to do this. Because we're talking about recursive, so you list out all of them. I'm not going to make you show your work for this because these timesing by 2 is something you can do really quick in your head. So after 1 hour, if it's doubling every time, the number of bacteria with it is doubling. So this would be 200, then I double it, 400, doubles, 800, doubles, 1600, doubles, 3200. After 5 hours, it's 3200. Just so you know, a lot of kids, they think this is the first hour, and they write this as their answer. And they'll get that wrong on their ACT. It started with 100. No time had passed when we had 100. So you have to maybe list them out like this so you see that after 5 hours, you have 3,200 bacteria, which is what I think we're talking about, right? Yes, so 3,200 bacteria, which is kind of creepy because that's what's happening on your desks when someone sneezes. But whatever, we won't talk about that. Okay, last one, number 7. Here's you practicing your recursive. It asks for the first 5 terms, so you have to see what it's telling you to do. My first term is 4, and that is listed 4. So here it's saying to find the next term, you plug in this term, and that gives you the next term. So it would be 4 times 3 minus 6. So to find A2, that's 3 times 4 minus 6, so it's 6. So A2 is 6. To find A3, now you're going to put a 6 in this spot right here. 3 times 6 minus 6, so 18 minus 6 is 12. To find A4, you're going to go 3 times 12 minus 6. So that would be 36 minus 6 is 30. And then lastly, A5 is 3 times 30 minus 6. So 90 minus 6, and that's 84. So just manipulating, seeing what it's telling you to do. Sometimes they'll have an n minus 1 here and an n here, and sometimes they have an n and n plus 1. This is saying this is the current term. That's the next term, so the one after that one. So on B, this is our first term, and this is our second term. So we actually already have the first two, don't we? And then it says, look at these notations here. This is the first term for what we're talking about, and this is the second term. This is how you would find the third term. See how they're just adding one every time? So to find the third term in this case, so to find A3, I would take A2 plus 2 times A1. So our A1 is 4, and our A2 is negative 3. So this would be negative 3 plus 8. So my third term is 5. Now, to find my next term, my fourth term, I would take my third term plus 2 times my second term. See how I'm substituting those variables? So A4 is my third term, which was 5, plus 2 times negative 3. So A4 is negative 1. And to find my last term, so my fifth term, to find my fifth term, I would take my fourth term plus 2 times my third term. So my fourth term I just found, 2 times my third term, so negative 1 plus 10 is 9. So my fifth term is 9. And that's pretty much as confusing as it can get. You know, it's quite a bit of work you have to do there. They're moving back and forth, but you're just trying to substitute those things. So if you have any questions on that, make sure you talk to me tomorrow.